Now let's talk about the yield from expression. Another interesting construct is the yield from expression. This expression allows you to yield value from a sub-iterator. Its use a lot for quite advanced patterns, and let's just see a very quick example of it. For that, I wanna create a new file called gen.yield.for.py. Inside, I wanna create a new file, a new function called print squares, like this. I wanna need a start parameter and also an end parameter. Inside, I wanna define a for loop saying n in range start to end. You get it? And we are yielding here n times 2, okay? So you can call that function like this: for n in print squares to 5 and print n, okay? I want to execute it. Gen.yield, and you've got 4, 9, and 16, which are the power of 2, 3, and 4. Another way to say the same thing, you can be a little more elegant. You can say something like this. Just copy this one, place it here, and then you can say it like this. Yield is in front. Then you can say yield from like this. Okay, I'm gonna execute it again. You must obtain the same result. Now, what about talking about generator expressions? The syntax is exactly the same as list comprehension, only instead of grabbing the comprehension with square brackets, you grab it with round brackets. Okay, it's called a generator expression. So let's see with an example. I wanna create a new file called generator.expressions.py. You could say cubes equal to key with a power of 3 for k. I'm sorry, k. What's k? K with a power of 3 for k in range 10. Okay, it's in range. Now you say print cube, and of course this one is a generator. Okay, generator expression. Let's see, and you've got here 0, 1, 27, 64, and so on. You could ask the type of this one. Cubes, and you've got something that a list, okay? Plus list, okay? That's a regular list. Now create it as a generator, okay? So I wanna say right here, just replace the square brackets to this one. With round brackets, okay? You can say cube like this, and let's execute it. Okay. Now, and the first one, and just already see it. Now you've got a generator object, a generator. Okay. If you wanna see the values, just say print. With list function, it's enough to exhaust the generator. Okay, you've got it there. Something else as watch out for extra parentheses when you write your expression. Sometimes it's easy to skip over these details, which makes your code very different. If you don't believe me, check it out. The following code. I'm gonna create a new file called sum.example to pi. Okay. Inside there, I wanna say s equal to sum. I wanna create a list called n with a power of 2 for n in range of 10 with a power of a. This instruction must kill your CPU, okay? And you see the difference with this one. I wanna say just delete the square bracket like this. In is missing here, so in. If you wanna kill your CPU, execute the first instruction. In other case, just print the second one. Okay. I wanna say some dot expressions like this. It takes a little of time, but it won't kill your CPU. Okay. Okay, you've got here the sums that is this value. It takes a little of time, but it won't kill my CPU. But in the other case, which is the difference, sweet generator expression, the difference between the two lines is that the first one, a list with the squares of 500 million numbers must be made before being able to sum them up. That list is huge, okay? We run out of memory. Therefore, Python kills the process for us. On the other hand, when we remove the square brackets, we don't have a list anymore. The sum function receives 0, 1, 4, 9, and so on until the last one, and the sum function sums them up, no problem, easily. Something additional that I have to say is the map function and also the list function, comprehensions, and run on in C languages. Okay, C language. Okay, so the speed within the interpreter. While Python for loop, I mean for, is run on Python bytecode. So within Python virtual machine, which often much slower. Take care of that. Another consideration I have to say is don't overdo comprehensions and generator. We've seen how powerful this comprehension and generator expression can be, and they are. Don't get me wrong, but the feeling that I have when I deal with them is that their complexity grows exponentially. The more you try to do within a single comprehension or generator expression, the harder it becomes to read, understand, and therefore maintain or change. Remember something, explicit is better than implicit, okay? Simple is better than complex. Read available counts, and also if the implementation is hard to explain, it's a bad idea. In conclusion, the moral of the story, okay, is that you try to use comprehension generation expression as much as you can, But if the code starts to be complicated to modify or to read, you might want to refactor it into something more readable. Your colleagues will thank you. Now let's talk about locations. Okay. Let's start with an example directly. I want to create a new file called scope for pi, like this. Scope for pi. Inside you can say s equal to 0, and also for in range 5, s plus equal to a. Outside I wanna print a. I wanna print also globals. Let's execute it with scope, and you've got here that s have the value of 4 in right here, and also in globals you can find s with a value of 10 and a with a value of 4. In the preceding code shows that after a for loop, if the loop variable wasn't defined before it, we can find it in the global frame. To make sure of it, let's take a peek of it by calling the globals built-in function.